Okay, find the value of the expression. Let's take a look at this one first. You can write it like this. Base of 3, 27 equals what? We don't know. If we change this to its exponential form, well, remember, the base is still 3. Here's the exponent. Here's the 27. So can you see x must be 3, because 3 cubed, 3 to the power 3, is 27. Okay, the next one. We can think of, again, base 3 to exponent of what will give me this 3. Well, of course, that's x equals 1. Okay? How about this one? Base of 3 with what exponent will give me 1? Well, anything to the power 0 will give you 1. Okay, so x equals 0. This one here, log base 3 of 1/27th. Now, it's going to be kind of similar. Think about this. Here's a 27, but here's a 1 over 27. So 3 with an exponent of what will give me 1 over 27. We've got to realise that this is negative 3. The reason is why it's negative 3 is because, again, if I flip it upside down, I change the sign of the exponent, and of course that will give me the 27, because that's what 3 cubed is. So there you go. So that is going to give you negative 3. And the last little one here. So again, this time it's a bit different to the rest. So you've seen all base 3s. This is now a base of 27. So a 27 to what exponent will give me that 3 there, okay? Now this, you have to realise, okay, so how do I get from 27 to 3? I am cube rooting it. That means that's an exponent of 1/3. If you remember, square root is 1/2. In fact, we're going to be looking at that when we come to this here. Square root is 1/2, cube root is 1/3. So the cube root of 27 is 3. So x is 1/3. Okay? Okay, let's look at question 2. Right, you can think of a as log to base e. ln is log to base e, and that's 15. If I change to exponential form, then e with an exponent of 15 equals x, and that is the answer. You can put it in your calculator, okay, but that's going to be a big number, but that's fine. That was quick and easy. Right, okay, how do we do this one? Now, there's two ways of doing this. I could change this exponential to log form. In other words, do the opposite of what I did up here. So, if I change this to log form, the base is 7, because it's the base of the exponential. 50 equals x. So that's really it. But of course, now we need the change of base rule if we need to put this in our calculators. So if I use the change of base rule and use natural logs, I could write this. It's the natural log of 50 over the natural log of 7. And that's what x equals, okay? That you could use log if you wanted to as well, okay? Change of base rule to give you the same answer. Okay, right. Now, that's one way of doing it, going from exponential to log. The other way is to log both sides, okay? Log both sides. If I write the ln of 7 to the x equals ln of 50, I've just written the word log or ln on both sides. You could use log base 10. I'm using natural log. The reason why is we bring this to the front, okay? Now, logs, they're just numbers. This is just a number next to a letter. If I divide both sides by it, then that is my answer, which is what we got last time as well. Log of 50 over the log of 7, okay? And again, you could put that in your calculator. By the way, think about this. 7 to the power 2 is 49. So, of course, this must be something a bit more than 2 to get to 50. And if you put that in your calculator, you see it's going to be 2 point something, a little bit more than 2. Right, expanding logs is question 3, okay? So, when we get to solving these, we're going to be condensing them, put into a single log. This is a single log. Let's put it into 1, 2, 3, 4 separate logs. There's 4 parts to this, so 4 separate logs. So, log base 5 of the x. Because the radical y is going to be a multiplication, we are going to add log to base 5. Now then, remember, the square root of y is y with 1/2. Remember how we did this one up here? Okay? So that is the exponent. And I'm going to subtract, because these others are being divided, I'm going to subtract log base 5 of 5 and also subtract log base 5 of z3. Now, sometimes I do get asked, well, wait a minute, I thought because this here is a multiplication, shouldn't it be an addition? Well, yes, if I wrote this, if I'm subtracting both things on the denominator, I could say that. But of course, this negative here will change this to a negative anyway. So I'm going to move everything back to what it was. Okay, that's what it is. Now, and again, just think they've come from the denominator. I think of these as minus. Right, I'm just going to write these exponents to the front of the log. So log base 5 of x plus a half log base 5 of y minus, now then, this log base 5 of 5, it's like this up here, okay? It's 1. And again, 3 log base 5 of z, and that is the answer, okay? Right, let's take a look at these equations here. In fact, you know what? I'll come back and do the equations in another video. Let's put that one on pause there.